This old decorative fence in our patio was probably 30 years old and falling apart. My spouse said it needed to be replaced. The original fence was built with turned deck posts. I wanted the replacement fence to look much the same, but I wanted to use full 8-foot fence posts, not 5-foot deck posts. No one sells turned fence posts, so I decided to turn them myself, which implies building my own lathe to turn them. These are the design criteria for the lathe. It must be disposable. I have only a mainstream suburban 2-car garage. When the project is done, the lathe goes away. The project must be cheap. I don't want to spend a bunch of money on a kit that's going to be tossed at the end. The project must be easy. I have only basic homeowner skills and tools. The project must be completed within my skills and tools. Please note, before this project, I'd never actually used a lathe, so if I get the terminology wrong at any point, please forgive me. Here is the spine of the lathe. Two 10-foot 2x6s held spaced apart with scrap 2x6 material. This is my construction for the headstock. A 1/2 inch drill is the motor for the lathe. 2 M8 bolts fit into the mount holes for right angle handles. A length of Holy iron stabilizes the handle end of the drill. I used a 2-inch hole saw as the bit. Then I added construction screws to secure the hole saw to the end face of the post. For the tailstock, I salvaged the front face of an ancient 1/2 inch drill. It had a sleeve bearing and a 1/2 inch chuck for another hole saw, and 4 convenient bolt holes for mounting. I glued and screwed a block to accept the old drill faceplate. Again, I used construction screws to secure the hole saw to the end of the post. I didn't want to invent some sort of screw-based adjustable mount, like a real lathe would have, so I held the rig firmly by hand and set screws through the spine into the end stock block. Now I needed to capture the original pattern off the old fence. I took my speed square and taped 2 pencils to it. The point of the pencil is barely protruding past the face of the square. The square keeps the drawing process perpendicular. This gave me a rough sketch on a piece of 1/4 inch plywood. As you can see, the drawing came out a bit rough. So after I captured the overall shape, I cleaned it up by hand. I used a jigsaw to cut the pattern, which was then smoothed and refined with a wood rasp. I had to devise a follow jig. I'm sure there is a technical name for this. I'm going to stick with follow jig. The jig has a bolt to secure my angle grinder at the mount for a handle. There is a 7/8 hole for a 1/2 inch pipe. The jig pivots on the pipe. There are 2 holes for zip ties that stabilize the angle grinder handle. The grinder is going to do the majority of the wood shaping. Here is the wood blade that will do that work. It is a 4.5 inch blade intended for a small skill saw. I had to bore out the arbor hole to 7/8 to fit the grinder. I've left an old masonry blade in place for design and construction because it's safer than the sharp, pointy wood blade. And I used an old abrasive metal blade to help guide design and construction. Here we see that the grinder blade and the guide blade are coplanar. These following slides show the parts of the follow jig assembly. First is a brace to attach the jig to the spine. A small plywood scrap is for stabilizing the pattern arm. You'll see its purpose in a bit. A pattern brace is next. The follow jig itself. The second pattern brace arm. Notice the pattern arms are mounted by a floating pivot hole. You'll see in a minute how this simplifies design and construction. Another scrap of plywood, and a right brace for connecting the follow jig to the spine of the lathe. On this slide, I'd like to point out two important radii. The distance from the pivot pipe to the center of the two discs are equal. This 1-to-1 ratio gives me an exact duplication of the original. Other ratios, say 3 times bigger or half as big, that math is left as an exercise for the student. Wood turning makes a lot of sawdust, so I'm moving the whole project out onto the patio for the duration. Here we see why I mounted the pattern onto pivoting arms. This allows me to place the edge of the grinder blade against the maximum diameter of the spinning post. I rotate the pattern on its mounting arms so that the guide disc fits right at the maximum extent of the pattern. I clamp the mounting arms to the plywood scraps to fix the pattern in place. Then screws hold it at the correct position for turning. Check the other end, set 2 more screws. Now we are ready to go. Here is my first power run, kind of like first light on a telescope. In this short clip, we can see several problems that I needed to solve before production. 1, the overall rig has a lot of lateral wobble. 2, my angle grinder was battery operated. Every time the battery toasted out, I had to dismount the grinder from the jig to change the battery. Even with 2 batteries, that murders productivity. 3, the grinder makes the follow jig very tip-heavy. It would be easy to lose control and damage the piece. I needed the tip to be lighter. 4, both tools are held in switched-on position with hose clamps. The drill is variable speed, while the grinder runs only flat out. I needed emergency easy-off switches. And 5, the jig was difficult to slide on the pivot pipe. My hands grew fatigued pretty quick, moving the jig left and right by small amounts. This was my first try to contain the sway from the machine. Cinder blocks. I was hoping the additional mass would dampen the lateral sway. They ended up not helping that much, but they did give me a nice solid tool rest for finishing tools, so the cinder block stayed there for the duration. These additions did resolve the sway. I put X braces on the legs of the sawhorses to stabilize the central structure. Then I added A-frames underneath the head and tailstocks. That firmed them up nicely. Now the wobbling was nearly eliminated. Good enough for my needs. To solve the battery problem on the angle grinder, I borrowed a corded grinder from a friend. Luckily, the mount hole on the replacement grinder moved the blade only about 1/8 inch from the original position. Not enough to worry about. To lighten up the tip on the follow jig, I drilled a hole and hung my screw bag on the heel of the follow jig. This kept the tip weight of this business end down to well under a pound. Easy to control with a light touch. This is my screw bag. It was a cheap but very satisfying impulse buy at the lumberyard. If you build stuff with construction screws of different sizes, you need one of these. For an easy shutoff on the drill and the grinder, I added a loop of parachute cord and a mini carabiner so that I could quickly shut them down. I kept in mind throughout the whole project that I was building something quite dangerous, so I tried to keep my body out of harm's way at all times. To make the pivoting follow jig easier to move, I attached a construction screw to the end of a 1-inch dowel for a makeshift push stick. I also smeared paraffin to the 1/2-inch pipe. By the end of the project, the paraffin had done the trick and the jig was smooth and easy to move by hand. Now for the first pass, rounding off the corners, removing the bulk of wood. I stopped the rough cut by hand about 1/8 to 1/4 inch away from the pattern, leaving some material for a second pass. Each bite only removes a blade width of material. This first pass was slow. With water breaks, this phase took about 1.5 hours per post. Here is an example of first pass results. Still pretty rough, but most of the material is gone. Now the second pass. As the guide blade glides along the pattern, the grinder blade removes the last 1/8 inch of material. Note that the paraffin has lubricated the pivot so that I am easily able to move the jig by hand. No more push stick. I found that dragging the grinder blade up out of valleys induced a lot of blade chatter. So I lifted the glide blade up onto the ridges and let the grinder glide slowly down into the valleys. This ended up providing quite satisfactory results. Also, cutting through wood knots resulted in initial blade chatter. You can see here that I penciled a K on the pattern to help me remember to go slow through knots. Now for the smoothing and finishing of the piece. For most wood turners, this is the most satisfying part of the process. This part made me nervous. Here I am in close proximity to a spinning 8-foot fence post on a homemade rig of dubious reliability. I could see ample opportunity for grievous injury. To keep my costs down, I used simple tools I already owned. I didn't want to invest in special lathe chisels that I would never use again. For sanding, I used a discarded belt from a hardwood floor refinishing sander, which can be seen inside the cinder blocks. The first post I turned had glaring defects. That's okay. I was learning the techniques and tuning the machine. So I purchased an additional post and made a 5th one and tossed the first one in the trash. The middle one, the 3rd one I turned, was best, probably because it was the best quality source post. Here the turn posts are set in concrete for the new fence. Let's take a brief look at the finished fence. My wife was very pleased with the results. She said, "Dave, I admire you for being so handy." Of course, it wasn't 15 minutes later, she's growling at me, "Dave, keep your hands to yourself." Let's recall one of the design criteria I mentioned at the beginning. The whole project had to be disposable. So, 2 hours after completing the last post, here's what was left of the lathe. I have no storage in my urban garage, so here are the reusable materials lined up for donation to a local theater company for set construction. Here's one more look. Thanks for watching, and remember, friends, be careful out there.